So this video is just about translators and interpreters. So if we've got some code that we've written, and say we've written a bit of, in this case it's Python here, the computer obviously can't read that Python for us because, as we know, the computer only reads binary, and the binary instructions that make up the program we would call machine code. So machine code is the way that the processor reads instructions and carries them out. So it reads that instruction that's stored in RAM, brings it back to the processor, decodes it, and then executes or runs the operation. So the computer doesn't understand the idea of if statements that we might write in a program, but those commands in machine code can be interpreted by the machine as what to do. So we need to do something in order to get our high level language, which is what this language is, high level language, into the lowest level language, which is machine code. And there are two ways to do that that we need to think about. The first one of those is to use an interpreter. So an interpreter is a piece of software that runs line by line. So it's going to take one line of code, read it in, and then consider how that's going to be run as a bit of machine code on the processor. And so it's going to use its own commands. So the interpreter has built-in machine code commands that will run on the particular processor that that interpreter is interpreting for. So each processor has an instruction set, and the set of instructions is all of the machine code instructions that the processor can recognize. So the interpreter for that set of processors, or for that kind of processor, is going to have built-in machine code commands that can be run on that processor. So the interpreter might have commands for adding and commands for loading and for storing and all sorts of other commands that would be able to make up our program. And each line it reads, it finds a relevant set of commands in machine code and sends them to the processor. So that means that every time we run the program, it's reading each line at a time and then interpreting that and using its own commands to run on the processor. So that can sometimes mean the interpreter's a bit slow because it has to do this every time it's run. Every line that's read, it has to do that. So it's slow compared to a compiler usually. And we'll think about compilers in a moment. It also means we have to have that interpreter software to run the program. So we need either the environment that we programmed it in or some interpreter software for it. So it needs the interpreter to run the program, which most of the time that's okay because we do have it. So if we're programming in Python, and if we're using something like REPL, or if we're using PyCharm or something like that, then that development environment has an interpreter built in, and when we press the green program running button, this is what it's doing. It's reading our code line by line. It's using its own built-in commands to run on our processor and show the results. So the other way of doing this is to compile the code. So compiling, sometimes we talk about making an executable. Making executable files. So sometimes, especially in schools, they don't really let you make executable files or run them for security reasons. But if we wanted to make a commercial program that we're going to give to someone else, they don't necessarily have the correct interpreter. We might be making an executable file using a compiler. So compilers, instead of reading line by line, a compiler is going to read all of the code, so the whole code. at once. It's reading every line of the code. So in this small program we've got here, it's going to read all of that. And assuming it doesn't come across any errors, then it's going to create an executable file in machine code for that particular processor. So compiled programs actually make machine code programs for that processor or processor type. So we can have a compiler that compiles the same high-level language. It can compile into a particular processor type, and we may have a different compiler if we wanted to compile it into another processor type, because the processors have different instruction sets. So in the compiler's case, we are actually making these noughts and ones of machine code. We're not running built-in commands anymore. We're creating a program that is standalone. It can run on its own without the development environment. So that is a compiler. They're often faster when they're compiled. So when a compiler's made the executable, it's often faster to run than an interpreter. If you're using obviously a program that needs a web-based environment, then compilers are not going to be the best option for that. Some form of interpreter is, because you can't tell what type of processor someone's using necessarily when they're online. So if you're running a program online, you're going to use probably an interpreter. So there's one other intermediate stage that we could do with a compiler, and we could make bytecode. So instead of going all the way to machine code, we could write some bytecode which could then be interpreted later on. So that bytecode is translated, but it's not translated all the way into machine code. It's something that another interpreter could run. So we could compile a program down to bytecode and then again use an interpreter, or sometimes they call them just-in-time compilers after that, to run that bytecode. So that could also be done. So they're the things that we need to think about for translating and interpreting. So if you haven't seen the video on levels of programming language, then it might be worth looking at that as well. But this sort of language, high-level language, this sort of language, machine code, is low-level language. So that's how to do interpreting and compiling. And so if they ask you questions like that in an exam, then the main points that you're thinking of for interpreter are that it runs line by line, that it has built-in machine code commands that it can run in order to execute it, and that it's not processor dependent. So it's not dependent on just one processor necessarily. Compiler makes executables. So it makes an executable file, runs the whole code at once, so it's looking at the whole code, and it makes actual machine code programs for that processor type. So you don't need the development environment once it's been done. At GCSE level, it's unlikely they're going to ask you too much about bytecode, but it's interesting to know that you can go to that halfway level if you want to with a compiler. They don't tend to ask so many comparison questions anymore, but if they do that, then interpreters, they're better for some environments, because if you don't know what someone's processor is, it's better, but they're slower generally compared to a compiler, because because they're doing line by line and they need to run every single line and find their own commands, and their own commands may not be as efficient as the compiler version, and they need either the interpreter or the development environment to run, whereas compiler doesn't need that, and you can make a standalone program to run. So that's a little bit about interpreters and compilers.